Hello students, today we're going to look at section 6.4, which is transforming linear functions. So we're going to take linear functions and we're going to do stuff to them, and we're going to see what we call that in algebra. But the first thing we need to know is that in algebra there's a parent function when we talk about linear functions. So the parent function is y equals x, or you might also see it written as the f of x equals x. Just a reminder, y and f of x both mean exactly the same thing. Okay? So the parent function is y equals x or f of x equals x. And when we graph the parent function, if you give me a y, x and y are exactly the same thing. So I would have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. I could have -1, -1, -2, -2, -3, -3. And this becomes the line that is my parent function. And all other functions can be compared to this parent function in 4 different ways. Okay? And so we're going to look at each of those 4 different ways. How can we compare the function to the parent function? The first way we can transform the parent function is by adding b. Because notice that on our parent function, it's not there anymore. Y equals x plus 0, b is 0, so it passes through the origin. So let's give me another function. How about y equals x plus 2? Okay? So when I graph y equals x plus 2, I can create a table if x, we'll put x and y. If x is 0, if x is 0, y is 2. If x is 1, y is 3. If x is 2, y is 4. And so we could graph those points. 0, 2, 1, 3, and 2, 4, and then my line would continue this way. Now what do you notice about those 2 lines? Yes, they are parallel, exactly. But what I did is I shifted the entire line up 2 places. So we call this a translation. With a translation, B is the one that changes, and it just moves the line up or down on the y-axis. Okay? So if I had the, let's use a different color. Let's say I have y equals x minus 3. I can just look at this and say, oh, it's the parent function, but it's translated down 3 points. So I could just go from the parent function down 1, 2, 3. That's where my y-intercept is. Up 1 over 1 for my slope. Sorry, right there, right there, right there. And then there's my line. So again, when B changes, we call it a translation. And this one would be a translation up 2. And y equals x minus 3 would be a translation down 3. Again, translation is when the B changes. The next type of transformation that we can look at is called a reflection. Okay? A reflection looks like this. Y equals negative x. How is that different from the parent function? Absolutely. The slope now is, instead of positive 1, the slope is now negative 1 in a reflection. That's the only thing that changes in a reflection. In a reflection, we have a negative slope. So what does this look like? I'll create my table. If x is 1, then y is negative 1. If x is 2, then y is negative 2. If x is 0, y is still 0. So let's graph that and see what that looks like. We're going to go ahead and do 0, 0, it's there. 1, negative 1. Cross 1, down 1. And 2, negative 2. And I could do this as well, just for visual sake. And that brown line is what we would consider a reflection, because it reflects across the y-axis. Linear equations always reflect across the y-axis. Once again, the thing to remember about reflections is that your slope is negative. If your slope is ever negative, then we call that a reflection when we're comparing it to the parent function. The last transformation that we're going to look at today is a stretch or a shrink. So I'm going to do stretch in blue, and stretch you could also think of as steep. Okay? Stretch happens when the slope is bigger than 1, or the absolute value of the slope is larger than 1. That means that the slope is getting bigger, and so it stretches or it becomes steeper. So let's look at an example. Let's do y equals 2x, for example. Okay? So let's create a quick table. X, y, 0, 0. If x is 1, then y is 2. If x is 2, then y is 4. If x is negative 1, then y is negative 2. Let's plot those points. 0, 0 is already plotted. 1, 2. 1, 2. 2, 4. 1, 2, 1, 2, 3, 4. And negative 1, negative 2. Negative 1, negative 2. So when I draw this line, notice how the blue line becomes steeper than the parent function, which is then called a stretch. Again, you need to understand that stretch and steep or steeper kind of are the same thing. So anytime that my slope is larger than 1, it could be like 5 over 4, that's still bigger than 1, or 7 over 3, that's bigger than 1, then that would be called a stretch or steeper. So let's look at what the shrink would be. I'm going to do that in orange. A shrink happens when the slope is between 0 and 1. Okay? So the shrink happens if, for instance, I have y equals, let's do 1/3 x. Okay? This one I'm not going to make a table because it'd be kind of crazy. So we're just going to use the slope and the y-intercept to create our points. Okay? So y equals 1/3 x. I know that my y-intercept is 0, so I'm just going to start at the 0, 0, and I'm going to go up 1 to the right 3 because slope is rise over run. So from the parent function, I go up 1 to the right 3, and then I go another one up to the right 3, and I go up 1 and another 3, and then I'm going to go down 1 into the left 3, and I'm going to go down 1 into the left 3, and down 1 into the left 3. And I'm going to draw that line that's going to go like this, and then like this. And do you see how now the orange line is not as steep as the parent function purple because my slope is a fraction that's less than 1. Now, even if it's a negative slope that's a negative fraction, that would still be a shrink, because we're looking at the absolute value of that slope. So let's kind of recap. It's called a stretch if my slope or the absolute value of my slope is bigger than 1. It's called a shrink if my slope or my absolute value is between 0 and 1, which would be a fraction. Stretch, shrink, and that's kind of what it looks like on the graph. A shrink is somewhat flatter, you might say, and a stretch is steeper than the parent function. So we've looked at several of the graphic representations of the transformations. Now let's just look at some linear equations and just see if we can tell from the linear equation what's going on in the transformation. So I'm going to start with y equals negative x plus 3. Okay? We've got two transformations in here. The negative tells me that's a reflection. This plus 3 tells me it's a translation up 3 because it's positive 3. So yes, you can have more than one transformation in an equation. Negative tells me it's a reflection. The plus 3 as a b gives me a translation up. Well, let's try another one. What if I have y equals 1/3 x minus 4? Okay? I know that the 1/3 x, because that slope is between 0 and 1, then that's going to be a shrink. And because I have minus 4, that's going to be a translation down 4 because it's negative. You catching on? Let's try another one. How about y equals negative 2x minus 1/2. This one is meant to confuse you just a bit, but let's look at everything. I've got a negative slope, so the negative tells me it's a reflection. Anytime you have a negative slope, it's a reflection. The 2 on the slope, even though it's negative 2, the absolute value of that is positive 2, so my slope is bigger than 1, or the absolute value of my slope is bigger than 1, so that means it is a what? Stretch. Because the fraction was a shrink, bigger than 1 is a stretch. And then I have minus 1/2. Exactly, it's a translation. And because it's negative, it's down 1/2. So we can look at a graph and we can tell what the transformations are. And we can also just look at simple equations to figure out what the transformations are from the parent function. And the last part of this whole concept with 6.4 actually spills over into 6.5 just a little bit, is what if I'm comparing two functions and the parent function is not even involved at all? I've got two functions. How are they different? Well, let's look at 2. So what if I have y equals 3x plus 4, and I want to compare that to the function y equals 2x minus 1. Okay? So let's just compare the parts of the things that are transformations. First of all, let's look at slopes. So I've got a slope of 3 in the first one, and we'll call it equation A, and then we'll call it equation B. For equation A, I have a slope of 3, and for equation B, I have a slope of 2. Well, the slope gets smaller, so B is a shrink of A. Another way we could say that is B is less steep than A. Because if the stretch made it steeper, then the shrink would make it less steep. Now what about the y-intercepts, 4 and 1? Okay? If the y-intercept is positive 4 here, and this y-intercept is negative 1, we know it is a translation down, but how many? How do I get from 4 down to negative 1? Just subtract those two. What's 4 minus negative 1 is 5. So B is translated down 5 from A. So just looking at these two functions, y equals 3x plus 4 and y equals 2x minus 1, we can compare them and tell how they're going to look different on the graph. B is going to be less steep, or A is going to be steeper, and A is 5 higher than B, or B is 5 lower than function A. So here are your practice problems for tonight's video. Compare each of these functions to the parent function y equals x. The first function is y equals negative 2x. And the reason I have two blanks is because there are two things that need to be written down. For y equals 1/2 x minus 2, again, there are two things that need to be written down. And for number 3, y equals negative 5/3 x plus 7, there are three things that need to be written down. Your options are translation, reflection, shrink, and stretch. Fill in the correct blanks, take a picture, submit it through Edmodo, and we're good to go.